Condition for buildup of voltage in a self-excited generator. In a self-excited generator, it is a compulsory that residual magnetism must be present in the self-excited machine. So there must be a residual flux in the machine. If a residual flux is not lost due to hammering while the transportation due to temperature, at a particular temperature magnetic losses magnetism. The temperature is skewed temperature disconnect the field winding terminal from the armature and connected across DC voltage source of low value and properly connected to the armature. So that means the residual must for a self-excited generator there must be a residual magnetism. A residual magnetism means the field poles must be having the retentivity property. So due to that retentivity property, the field poles produce a flux even though there is no current or there is no supply is given to the field winding. Then also the field winding produces some flux, that is a 4 to 5% of the total flux. That flux is called the residual flux. Sometimes this may be lost due to the transportation in the transportations, or sometimes maybe it lost due to the temperature rises. So so the residual magnetism may be lost. So this residual magnetism will be recovered by connecting this field winding to a separate DC source and energize. So then it will be the residual magnetism will be again established in the field poles. The process of re-establishment of residual flux in called field flashing. Field flashing. At the time of starting, if generator does not start, it may be due to wrong connection of field terminals to armature. Field winding terminals are properly connected to the armature in a such a way that further produced flux should aid the residual flux. Aids the residual flux. So OCC characteristics and Ohm's law are required to explain this residual flux. So OCC curve is drawn between the field current and EG generated EMF. So in the figure we see the OCC curve and field resistance, vary the field resistance at different values, RF1, RF2, RF3 and RC. Here RF3 is greater than RF2 and RF is constant and RC is greater than RF3. DC generator generates the voltage at which the OCC meets the RF. This is that stable operating point. So in figure we can see that G is the stable operating point. RF is the field resistance, constant field resistance. Stable operating point changes with the change in RF. Indian. The resistance of field winding RF increased at one value of RF curve becomes tangent to the OCC, and this resistance is called critical resistance. At this resistance, voltage will be built up. If the resistance is further increased, voltage will not build up. So always RF value is less than critical resistance for voltage to be built up. So see here the OCC curve. In OCC curve, OCC means open circuit characteristics. It is a curve drawn between the EZ and IF. So in that, RF is the constant resistance. If RF values are increases from RF to RF2, so then it's also cutting the OCC curve, and again RF2 to RF3 is increasing, so field resistance. So the RF3 also cutting the OCC curve, and if the field resistance is increasing from RF3 to RC, then at this point the RC is cutting to the OCC tangent. If field resistance is increasing above the RC value, then that resistance will not touch the OCC curve. So the EMF generated by that generator is zero. Generator is zero. The resistance is increases if the field resistance is increases. If the field resistance is increases above the RC value, then EMF generated by the generator is zero. The EMF generated by the generator is zero. So always RF build up the voltage. For voltage to be built up, if the speed of prime mover changes, critical resistance also changes. If speed increases, critical resistance increases. At constant speed, critical resistance also constant. Speed of prime mover changes, critical resistance also changes. Speed increases, critical resistance increases. So very important that the field resistance value must not be greater than critical resistance. So if field resistance value is greater than the critical resistance, the generator will not build up, because the field current IF equal to V by RF. The field current IF equal to V by RF. So RF is the field resistance. If the RF values are increases beyond the value, if it is increases, then IF values will be decreases. If the IF values are decreasing by increasing the RF value, then at certain level, that means RF is crosses, when RF is crosses to the RC value, then the field current values must be downward, and the flux produced by the field current will be minimum, that is a very less. So in this condition, the generator will not build up the voltage, and there is no magnetic field present in the generator. There is no magnetic field in the generator. If the speed of the prime mover changes, critical resistance also changes. If speed increases, critical resistance increases. At constant speed, critical resistance also constant. Constant speed, critical resistance also constant. Critical resistance is proportional to speed of the prime mover. So it is a critical resistance is proportional to speed of the prime mover. RC2 by RC1. So at a different two speeds. Here two speeds. IF versus E0, that is a OCC curve, that is open circuit characteristics, are drawn between IF, the field current, versus generated EMF for two different speeds. At N1 equal to 100, not 100, it is 1000 RPM, and N2 equal to 1200 RPM. So when the speeds are increasing from 1000 to 1200 RPM, critical resistance value also increases from RC1 to RC2. So in this the RC1 is given but RC2 is not given, so we need a RC2. So for RC2 calculation, RC2 means critical resistance 2, because at speed 2, so the RC2 equal to N2 by N1 into RC1. N2 is a 1200 and N1 is a 1000 into 200 by 240 ohms. The speed at which OCC becomes tangent to the RF curve is called critical speed. If speed further reduced less than critical speed, then generator fails to build up voltage. Speed of prime mover is greater than critical speed. If speed of, again, the speed at which the OCC becomes tangent to the RF curve is called critical speed. So here is the critical speed where the RF values are cutting to the tangent. If the speed further reduced to less than critical speed, then generator fails to build up the voltage. That means if the generator speed must not be less than the critical speed. Speed of the prime mover is greater than critical speed for voltage to be built up. Critical speed depends upon the field winding resistance. RF equal to 200 ohms, N1, N2, NC, IF, E0. NC proportional to RF. NC means critical resistance. NC proportional to RF. NC2 by NC1 equal to RF2 by RF1. NC2 equal to RF2 by RF1 into NC1, that equal to 180 by RF1 is 200 into 700, that equal to 630 RPM. 630 RPM. 630 rpm. So the compounding, adding series number of turns to the shunt machine. Compound machine is modification of shunt machine. Shunt flux is more dominating in compound machine. Here compound machine means adding series number of turns to the shunt machine in a classification class. So the compound machine is explained now here. There we explained shunt and series machines. Now here a compound machine. In a compound machine, for a pole core, on a pole core, series turns and shunt turns are wounded. Series and shunt turns are wounded. And firstly, actually the shunt turns are wounded because the number of turns of shunt turns are more. Because of number of turns are more, because resistance has to be more for a shunt field winding. It's very important. The resistance of shunt field winding must be greater because it carries the lower current. So whenever the shunt field turns are more must be more. So when the shunt field turns are more, then it should be accommodated first on pole core, and next the series field turns are wounded on shunt field windings. So shunt flux is more dominating in compound machine. Shunt field is more dominating in a compound machine. Over compound, level compound, under compound, shunt machine, differential compound machine. These are the different generator load characteristics. Over compound means pi sh plus pi se. So in a over compound, the generated EMF is greater than the terminal voltage. Level compound means E naught equal to V, and under over compound E naught is the generated voltage and V is the terminal voltage. So terminal voltage is greater than generated voltage. In under compound E naught is greater than V. By connecting the diverter across the series field, based on type of coupling, compound machine classified as aiding flux, cumulative, opposing flux, differential between shunt and series flux. Cumulative pi sh pi se, pi r is greater, that equal to pi sh plus pi se. Differential compound, pi sh and pi se is opposing, series flux opposing the shunt field flux. So how to change type of compounding? Cumulative differentiative by reversing the current direction in one of the field, then type of coupling or mode of compounding changes. If change is made is both the fields, then type of coupling doesn't changes. So cumulative and differential by reversing the current direction in one of the field, then type of coupling or mode of compounding changes. So just the direction of current, if the direction of current changes, then it changes the cumulative or the differential compounding. If change is made in both the fields, then type of coupling doesn't changes. So at least one of the field winding must be changes their direction, then only compounding will be cumulative or the differential compounding will be changes. If long shunt cumulative compound generator is to be used a motor, then it operates as a, if a long shunt cumulative compound generator is to be used as motor, then it operates as a long shunt differential compound motor. So long shunt differential compound motor, because the current directions are reverse in a motor, but flux of two shunt and series poles are opposing, see in the figure. So it is a differential compound motor. Short shunt, if coupling changes, type of coupling only changes but not type of construction. So the construction will be same, because long shunt means it is a long shunt. The generator may be a reverse, so it may be act as a motor. The cumulative, in place of cumulative, it is a differential, it becomes a short shunt differential compound generator. If it is converted into the motor, then it acts as a short shunt cumulative compound motor. See the short shunt, and here also short shunt. In place of differential compound generator, it acts as a cumulative compound motor. Because here field directions are not changed, field connections are not changed, just generator is acting as a motor. If just generator only acting as a motor, a short shunt cumulative compound generator act as short shunt differential compound motor. Long shunt differential compound generator as a long shunt cumulative compound motor. Long shunt cumulative compound motor, if supply terminals are reversed, then act as a, so here long shunt cumulative compound motor, if supply terminals are reversed, then it act as short shunt. AB is the wrong, because of a long shunt machine will be a long shunt only, because the construction is not changes. So the option A and B are wrong. And in the CD, so initially the question is long shunt cumulative compound motor. So the long shunt cumulative compound, because of it is a cumulative compound, because the reversal of current, the compound machine converted into the differential machine. So if the supply terminals are reversed, then it acts as a long shunt differential compound motor. Write that, long shunt differential compound motor. Long shunt differential compound motor. So see, again observe that cumulative means the field fluxes pi sh and pi sc same direction. Differential means pi sh and pi sc in opposite direction. So see here, if the two, so it may be a generator or motor, a cumulative compound generator or motor. Mode of compounding is independent of supply terminals connection in case of motor. A compound generator is running in a differential mode. Very important. A compound generator is running in a differential mode, generated 220 volts. Again, a compound generator running in differential mode generates a 220 volts. Suddenly, series field is short circuited. Suddenly, series field circuit is short circuited. Then it develops a greater than 220 volts with the same polarity. Then it develops a greater than 220 volts with the same polarity, because in a differential compound machine, pi sh minus pi sc. See carefully, in a differential mode, pi net flux equal to pi net equal to pi sh minus pi sc. Here pi sc is short circuited, so the pi sc value is 0. So the net flux is pi net equal to pi sh. Pi net equal to pi sh. So when pi net equal to pi sh, so because of pi sc is 0, the net flux available in the machine is, in the generator, is greater. So when net flux is greater, then the voltage developed by the generator will be greater value. A compound generator build up, that means a differential compound generator build up a rated voltage. A differential compound generator build up a rated voltage if suddenly shunt field is opened. Suddenly shunt field is opened, then it develops a no voltage. Why? Because the net flux becomes a negative, because pi net equal to pi sh minus pi sc. Now pi sh is short circuited, so the pi net equal to minus pi sc. So the negative flux which opposing the residual flux. So because of this problem, the residual flux will be losses the machine. The generator will losses the residual magnetism. So in a differential compound generator, the shunt field will not be short circuited. If the shunt field is short circuited, then the machine will not build up any voltage and it lost the residual magnetism also. It lost the residual magnetism also. If a series field flux is more than the shunt field flux in above question, the EMF developed will be more than the rated if shunt field is open. So in this, again, in a above question, here actually pi net equal to pi sh minus pi se if it is a normally given, but here pi se is a strong field. That means a series field is stronger than the pi sh. If the series field is stronger than pi sh, then formula is pi net equal to pi se minus pi sh. The series field minus flux in series field minus flux in shunt field. If series field flux is more than the shunt field flux, the above question, the EMF developed will be more than the rated if shunt field is open. If series field short circuited are provided, pi se values are greater than the pi sh, then net flux becomes a negative and no EMF will be developed. In compound generator, next question, in a differential compound generator, if strong field becomes zero, then no buildup of voltage because negative flux will be present. If weak field is becomes zero, then buildup of voltage more than rated voltage. In a compound generator, cumulative connected, if any one field should short circuited or open, then the net flux reduces, then it produces a less than the rated voltage. In a compound generator, cumulatively connected, if any one of the fields should short circuited or open, then net flux reduce, then it produces less than the rated value. In motor, if shunt field open, motor runs resultant DCM, differential compound motor. Flux reverse, motor runs in a reverse direction but with below rated speed. In a differential compound motor, if series field becomes zero, then motor runs in a reverse direction. Field becomes zero, then motor runs in a reverse direction. If weak field becomes zero, produce a more than rated torque and runs with a less than rated speed. More than rated torque and runs with a less than rated speed. how to change the direction of dynamically induced EMF? Either by changing the direction of rotation or by changing the flux direction. Either by changing the direction of rotation of prime mover or by changing the flux direction, but not both. Then the direction of dynamically induced EMF changes. Then only the direction of dynamically induced EMF will be in order to change the direction, the rotor has to be stopped and then it should be reversed. So it is that. So Eg proportional to pi n flux into speed. It is from is equal to pi z n by 60 into p by a. Pi flux, z conductors, n speed in rpm. So a generated EMF is directly proportional to flux and also directly proportional to conductors and also proportional to speed. So now it is I want to change the direction of generated EMF. So to change the direction of generated EMF, we should change the speed direction or change the flux direction, but not both. So at present Eg proportional to pi n, that means flux and speeds are in a correct direction, in one direction. Then positive EMF will be present, that is the reference. Now if in a case second Eg is proportional to minus pi and n, so in this condition the flux directions are changed and speed directions are remains same. Flux directions are changed and the speed directions are remains same. So in this condition the Eg values are negative. Eg proportional to pi minus n. So in this condition minus n means the direction of rotation is minus, that means reverse. So here also the generated EMF is negative, and now the flux direction and speed direction both are reverse. Then there is a positive EMF. A shunt generator running in a clockwise built up a 220 volts. If suddenly direction of rotation is reversed without changing in its field winding terminals, then it builds up the rated voltage is not possible. Again, a shunt generator running in clockwise, it builds up a 220 volts. So one shunt generator is running in a clockwise and it's building a 220 volts. If suddenly direction of rotation is reversed, okay, without changing in its field winding terminals, so just only direction of rotation is changed, then build up a direction of rotation is reversed but field winding terminals are not changed, then build up a rated voltage is not possible as a flux opposing the residual flux. So here is a flux is oppose the residual flux. Series generator also cannot build up the voltage in this case in any self excited generator by maintaining the field winding terminals as it is. If the direction of rotation reverse, then no voltage is built up. In case of separately excited generator, if the rotation is reversed, then it voltage build up with the reverse polarity. If the rotation is reversed, then it voltage build up with the reverse polarity. In shunt generator, if both N and field windings are reversed, it will build up a voltage with the reverse direction. In series generator, if both N and field winding terminals are reversed, it build up voltage with the reverse polarity. It build up with a reverse polarity. Again, in a shunt generator, if both speed of prime mover and field terminals are reversed, it will build up a voltage with a reverse direction. In series generator, if both N and field winding terminals are reversed, it build up a voltage with reverse polarity. In any self-excited generator, if both N and field winding terminals are reversed, it build up a voltage with a reverse polarity. Separately excited generator, if both N and field winding terminals are reversed, it build up voltage with the same polarity.